Okay, let's get going. We're back for data structures again. Today is the 29th of January. Here's what we're going to do today. Hopefully all you guys finished up the lab yesterday. You should have finished up. If you didn't do it yesterday, you did it on Monday. And I wanted to I'll talk a little bit about the lab and what's expected of that. Most of you guys did very well. But I've got some comments about the lab as well. So here's what we're going to do today. We're going to do a little Unix tip of the day. Okay? And it's probably the most important tip because it's really the only tip you need to do whatever you want in Linux and Unix. Okay? And it is probably the only tip that you will go back to the entire rest of your Linux career. All right? Or Unix career. All right. I don't know why that has a Postmortem H on it, but we're going to talk about lab 1. Then we're going to do a little bit about these little C++ kind of groundwork, okay, to talk a little bit about these things called references versus pointers, which you've seen before, and this idea of passing something to a function by a reference, or pass by reference, or pass by value. Okay, I guess I should probably say pass by value, which is what we'll get to. And then we're going to go into, so last week we talked about, or on Monday we talked about singly linked lists. And then today we'll do doubly linked lists. And then finally I'll just throw a little thing in there about circular lists. Okay, any questions on administrative issues so far? OK. By the way, before I actually go on to the stuff, I've been talking to a couple people in the class, and they've said, hey, you know, this is all review from Comp 11. Right? So far, a lot of this stuff has been review. I mean, I've thrown in some new things that I think you guys haven't seen before. I am perfectly willing to try to speed things up a little bit. But what I think is important is, even though some of this is review, it's like, you know, going back to the groundwork to try to kind of, if you didn't quite get it the first time, maybe you'll get some of this stuff this time. Okay? So if you do think we're going a little too slow in here, bear with it for the next week or so. Next week, I'm fairly certain we'll see stuff that some of you have, almost all of you have, like never seen before. So we'll get to that stuff. But for now, we're just kind of going through this stuff to get us back up to speed. Besides, it was all the way back in like December when you took a class before, right? So still, we've got to do a little bit of catching up, or a little bit of refreshing anyway. OK. So here is your Unix tip of the day. The man command. OK, that is not a sexist command. It actually stands for manual. Okay, and it tells you how to use a command. Okay, and this is why it's so important, because if you don't know how to use a certain command, you can type man and then the name of the command, and it gives you all the information you need to know about it. Most of the time it's all. Not all the time it's all, but most of the time it's enough to at least get you started. Of course, you can also generally go to Google these days, but let me show you what this actually means. Boy, that's big font. All right, so if we type man and then say ls, right? What it does is it gives you this little, it tells you what the command it does, in this case list directory contents. Then it gives you all the different flags for it, right? Now notice there's like a billion flags, right? There's a lot of different stuff the ls command can do to format your code appropriately, okay? All these different things. Well, obviously you're not going to memorize them all, okay? I don't even think the people who designed ls probably have them all memorized. Right? And then it gives a little description, and it tells you a little bit more about what the command itself does. But really the important part is it gives you the actual, it lists out all those flags and what they actually do. Okay? So if you want to list, include directory entries whose name begins with a dot. I can't read that here because I didn't format this properly. But begin with a, ooh, still not there, hang on. There we go. Let's see if there we go. That's about right. And I'll move that over there. OK. And then I'm going to do my window refresh to get it working right. Oops. No, I won't. There we go. OK. So anyway, it gives you all the different flags that you need in there and tells you a little bit about it. Some of these man pages, which they're called, you can do space to go down each man page. I'm hitting space continually here. Right? It will end up, sometimes it gives you actual examples as well. If you really want good examples, you can go to Google and find out. But the manual page will tell you a lot about that. You can also do a search. Man-K gives you a keyword search. So if you want to say something like you're looking for something about the disk, right? You do man-K disk, And it will tell you a whole bunch of manual or pages that you can go to and look up for that page. So it's nice. It gives you a little bit about what each command does and tells you how to use it. Okay? So that's the Unix tip of the day, the man pages. All right. Any questions on those? Shouldn't be. OK. All right. Now, a little bit of a postmortem on the Hookbook lab. Again, good job overall. I totally understand that it's hard to write code given an hour block of time and to try to understand it all, figure it all out, and then actually sit down and write your code. Every piece of code you ever wrote in your life probably has one bug in it that you have to go back and fix. And it takes time to fix those, and it takes time to kind of think about this. So if you didn't finish your complete assignment during the lab, that's actually OK. You provided something, hopefully. If you haven't, please go back and actually provide what you did in the lab. And that will suffice for showing that you went to lab and worked on the assignment. And what we're all looking for is that you've tried on the assignment and you've actually put the effort in to try to get something on the page that actually makes sense. Okay? If you don't have a perfect running code by the end of the lab, that's all right, as long as it showed that as long as you've demonstrated that you're starting to work on some of the concepts. Okay? The other part of the lab, by the way, is just the idea that it's a smaller group and you can ask questions in there and you can actually get a little bit of targeted help right while you're doing that. So keep that in mind. And I'm totally cognizant of the fact that it is tough to write code in a short amount of time when you can't process some of that. And some people are great at it. Some people, it takes me a while to write some, to sit down and concentrate, especially when somebody's staring at me trying to do it. That's tough too. So I understand that. Keeping track of all the details of this was tough. Because we had a linked list, a dynamic array inside a dynamic array, you had to take into consideration, first I look through that pirate list, and then using the one that I found that's the right member, then I need to do something with the data associated with that pirate. That took some people a while to get their heads wrapped around. And again, it doesn't surprise me. Okay? If you do want more help, we're not going to provide a detailed feedback like we did on the homework assignments. But if you do say, hey, I still didn't quite get what was going on in that lab, go to the office hours. We'll pull it up on your screen, and then we'll walk you through some of it there. Okay? Any other questions on that part of the lab? Like the details of that? OK. I do want to show you one thing that a lot of people, almost every time I went up to a student when I was doing the labs that I was in, whenever I went up to a student and said, OK, what's going on? They said, something's not working here. It's seg faulting, or it's not providing the output I want. The first place we looked is in this expanding of the dynamic array. Okay? And you probably went over this in the lab itself. But there are 5 different things you need to think about when you're expanding a dynamic array. Okay? Let's look at them. First thing. First, you create your new temporary array. Okay? That's the first thing. It's going to be a pointer to an array, and then you use the new keyword to do that. Okay? I'll show you the example of what I came up with in a second. Then you need to take that new array, which hopefully is bigger. That's the point of it. It's bigger than your previous one. And you need to copy every single element from the previous one into the new array. And that's going to take a loop. You're going to have to do that in some sort of looping structure to do that. Or you could use a library method called copy. But if you do that, you should document it and do that. But you really, under the covers, that's doing a loop. Okay, is what that's doing. All right. Then you need to actually delete the old array. If you don't do this, it is not the end of the world. Your program will probably still run. Okay? It does leak memory. And when we get into more advanced programs where you're going to be deleting and expanding arrays a lot, you could run out of memory. So you do need to delete the old one. And I'll show you the specifics of that in a second. And then you need to, and some people forgot to do this part, you need to set the old array pointer to the new one you just created. Right? You just deleted this one pointer, and so now it's kind of pointing into nowhere. You need to set that to that new, bigger structure. And then finally, you need to update the capacity. A lot of people forgot to do that too. If in that struct that you had of the friend list capacity, I guess it's friend capacity, it went from this big to now this big. But you need to tell the program that you've made it bigger. Right? Just because you created a new, bigger array, the program can't figure out, oh, now my capacity is bigger. You need to actually set that in there, which I'll show you as well. Okay, so there's 5 things that you have to do when you're creating a new, when you're expanding an array. Okay? All right, so here's what I came up with. And I'm sorry I didn't actually format it so it's that easy to read. But in this case, I'm saying that I've already found my pirate that I needed, right? The one that's a member ID. And the I index is going to hold the number of that pirate in my pirate list. OK, so I'm going to go through the 5 steps. First things first, I'm going to create this new pirate. Now, this whole business, this took some people a little bit of time to understand. HBook is all your pirates. I is the pirate you're working on. So you need to refer to that pirate with this. Then the structure of that pirate is the name of all those different elements in it, one of which is the friend capacity. And this is where you're multiplying by 2 to increase it. OK, so we do that. Check. Step 1. Now we have to copy it. OK? I used a variable copy count. You could use j if you want. Some people tried to use I again, right? There's a problem with that. Well, in this case, it would actually work. Well, it wouldn't work directly because you've got to use I here. So you can't use I again. Okay? You have to use some other variable. Try to name your variable something interesting, something that makes sense. For simple loops, you could probably use I. I probably should have used index up here or pirate index or something like that. Okay? But anyway, I'm copying everything over. What's going into my temporary variable at the copy count location is what was in my friends list, or is in my friends list, at that same location. I copy it in. Now I'm done with the old one. The old friend list, I can just delete it. This line right here says delete the array that is at this pointer. Okay? And the memory system takes care of all that for you. When you use new originally to make your friend list, the memory system has a pointer that says, or a structure that says, here's how much you asked for, and here's where it's located, and then I'll be able to delete it. Right? So it keeps track of that. So you can delete that. That does not delete the friend list pointer. It deletes what it's pointing to. Okay? And then we have then we've got to do this setting the friend list to what we just created. Some people forgot this line, which was like, oh, you wasted all this other stuff. Right? And you ended up with a deleted pointer, so you're going to almost certainly crash your program. You have to set your friend list equal to that new one that you just created. And then finally, you have to update your capacity in the same pirate thing. Okay? So I just wanted to refresh that because you'll see it again and again, and we'll do lots of examples, or you'll have to do this in a lot of your programs. So make sure you got all the steps in there. Okay? Questions on that? All right. OK. Let's see. Was this? Oh, that was from last week. I don't know why that's still in there. OK. All right. So here's the next thing that I'm going to show you. OK. I'm going to pull it up I'm going to pull the actual code up as well. In C++, OK, when you are providing arguments to a function, OK, you can provide them by reference, which means you're going to have this little ampersand here in the function definition, not when you actually give the variable to that. You've seen this before saying, hey, that means give me the address of what my variable is. This is not really what we're doing. Kind of under the covers it is, but this is not really what we're doing. What I want to do, I want to show you this example here. I want to do a little swap. So I have like some variable a equals 2 and b equals 5. And I want to swap those two. Okay? It's a pretty simple algorithm to actually do this swap, right? First thing we do, we can't say a equals b, because then that loses the value of a, right? So what you would do is you would say something like, let's say these are integers. You would say something like int temp equals a. Then we've stored the value of a equals b now. And we move the value of b into a. And then we can now say b equals temp, which is going to say, OK, now a, what was a is now in b. Does that make sense that we've now swapped what these two variables are? OK, you can do that in your code, but what if we want to write a function to do that? So every time, let's say we're doing some program where we're swapping values all the time, right? That actually is relatively common. We can write this into a function. The problem is that the way C and C++ works in general is that it's not as simple as just doing it. OK? I'll show you the example in a second. if we declare it like this, what it's saying is to the program, give me a reference to the original A and B. In fact, well, I'll leave it as A and B out here, but give me a reference to that, meaning that I can go and adjust that variable itself. Okay? You can change the value of this that will be reflected in the original calling function by doing it this way. Let me show you a way that it won't work. If you just passed it like this, swap A and B like this as integers like that, the compiler actually makes a copy of both A and B and provides that to the function. Why does it do that? Well, it has to do with the way that the semantics of the language itself. But the point is that you don't actually get the original value that or the original variable that you're sending in. You get a copy of it. Okay? In our swap function, which I'll show you, you actually don't get to change those variables such that they will be reflected in the outside program, the one that called the function. Okay, you get these copies. We could do it slightly differently. We could say it this way. This is a third different way of doing this. Okay? We could pass the actual pointer. So in other words, you can say, hey, I'm going to pass you a pointer to A, and I'm going to pass you a pointer to B. And then in your swap function, which you have to write a little bit differently, you can change those variables. You have to dereference that variable, and then you have to actually go and then that will actually give you the address, which will allow you to make that change. Okay? Now, let me pull this up. I forgot that I was going to do this, so it's going to take me 1 sec to pull up. But let's see, maybe it's there already. Pointer versus reference, it is there. OK. So unfortunately, the program I'm using doesn't actually allow you to make the size. Whoops, I did the wrong one. Hang on. Nope. That one, and then, OK. It's a very simple program. OK? It is a very simple program here. What I'm going to do is show you the whole thing. All right? Like this. OK. So I've got 3 swap functions that I've created. OK? I've got 3 swap functions. OK? The first one just says, give me A, give me B. Right? And then it tries to do this little algorithm. OK? And it doesn't return anything. It just says, I'm going to make those changes. The second swap says, give me a reference to A and a reference to B, and does the same thing. And then the third one, which you would have been able to do last semester if you hadn't known about references, is this one, where you get a pointer to A and a pointer to B. And notice what we have to do. We have to say temp equals the dereferenced value of A. In other words, A is the pointer. We need to get what it's pointing to. Move that in a temp. We need to change what A is pointing to be what B is pointing to. And then we have to change what B is pointing to what temp is. OK? So it looks it's a little bit trickier to get that right all the time. OK? This one was easy. A equals B, B equals temp, boom, we're done. All right. And then this is what the function is going to do. It's going to just set A equal to 2 and B equal to 5. OK? And then it's going to tell you what it is. And then it's going to try to swap it using the first function, and then the second function, and then the third function. OK? And we'll see what actually happens here. Hopefully this will work. All right. Gave me a little window down here, but you guys can kind of see what happened here. OK. So it says A equals 2 and B equals 5, which is what we've got. Swap them using this first function up here, okay, where we just pass in the pointers. Remember, we're getting copies of these. Well, guess what? If we do it that way, A is still equal to 2 and B is still equal to 5. Not what we were expecting, okay? Because we did do the swap. And up here, if you had used, so if I had gone up here and I said, you know, C out A, right? It would have said 5, which is what we were expecting. Because up here, inside the function, it does do that properly. OK, it does do that properly. But once you go back to your original calling function, those were copies of those variables. OK? And so it means that you can't actually get the values back the way you think you might. OK. In the other two cases, so now we're going to swap A and B. And first of all, they equal 2 and 5. And now if we do the swap 2, which is the reference one, hallelujah, it does work. Right? A equals 5, B equals 2. And then, by the way, I'm swapping them back again. So this might look like I should have reset them. But I'm swapping them back again with our little pointers to A and pointer to B down here. Right? If I do that, it swaps them back to being 2 and 5. Okay? So do you see how that works? If you want to look through this code a little bit more, go right ahead. And you can see it on the website. And you can actually walk through it and see what happens. OK. All right. Questions on that? Yes? Oh, yeah. Good point. So main does have parameters. These are the parameters that if you typed it into the command line and you typed something else after that, you would get those into your program. You don't have to. Normally, we write this with just, we don't actually write this. We would do it like that. And that would work just as well for this program. Yeah, this program would work just as well. In fact, if you use Clang with the warnings we've suggested that you use, it will give you a warning if you do this and say, hey, you don't use these. Why don't you use these? Right? So in this case, we're not using them for this program. Yeah. Yes?
You said there's a difference between reference and pointers.
Mm-hmm.
What's the difference between passing something by reference?
Good question. OK. So in C and C++, if you don't use this special form where you're passing this by reference, everything gets copied and passed in. Okay, to the function. Now, if it happens to be a pointer, just the pointer value gets copied and passed in, which is what we're doing right here. If it happens to be a pointer, that pointer value gets passed in. But again, they do it because of the semantics of the language. They want to be able, they want you to be able to modify things without destroying the original copy. The original is the reason they do that. Yeah. Is there a better way? Like, is one of these better than the other? Depends. I mean, if you want to be able to convert your programs back to regular straight up C, yeah, you've got to do it this way. If you want it to maybe look a little easier and just be a little easier to deal with, you can do it with the reference here because there's no bothering with pointers here. It happens to be a little safer. There are some mistakes the compiler can pick up on a little easier if you try to do something with that. So it's a little easier. All right. Any other? Yes.
What if for the thread tree you just have arguments A and B? Your main function.
Did I do that? What did I in the main function? Oh, in the main function, I said, give me a this is actually a pointer to A. This is saying, give me the address of A. You know, it's funny. It looks like it should be backwards. Like it looks like it should be the other way around, but it's not. This is saying, in swap 3, it's expecting a pointer to A. You can get the address, which is what the pointer is pointing to, by using an ampersand here. So I kind of wish they had used a different thing instead of the ampersand. I mean, somebody who wrote this said, well, it makes sense because it's kind of a pointer, like a pointer, but it does make it a little more confusing. Yeah, I'm not going to apologize for that, but it does make it a little more confusing. Anything else on this? OK. You won't see that too much in here, but you're going to have to use it at various points. OK. So let's go back here. All right. OK. So let's get back into some of these linked list ideas. Your next assignment, by the way, is going to start us off on what may end up being a few assignments or a couple of assignments. Does anybody use their phone with a calendar function? OK, yeah, most of you guys do, right? Bruce and I were talking about this earlier. Does anybody actually have a paper calendar anymore? You write anything in? Yeah, a couple people do. That's fine. It works, still works. Will work when the power's out, when your battery's dead. No battery necessary, right? But if you want to, somebody had to write the program for your little calendar, right? Do you know how that program actually works? Like what's going on underneath the covers there? Well, they have to obviously use some data structure to represent dates, appointments, and conflicts between appointments and all that. So some of the things that we're gonna start thinking about is how your calendar in your phone, let's say, works. Okay, so the next assignment is going to be kind of doing like a basic calendar. Okay, but we still need to do a little bit of setup, And by the way, there are lots of different ways to do that. Lots of different data structures you can use. In fact, the ones that we probably come up with are possibly not the ones that your phone uses, but But it'll be similar in the sense that you'll get the idea of what's necessary to actually build it. OK. So the other day, we talked about linked lists. OK, we had linked list up here, and we had a couple of different links and a bunch of nodes in here, right? And the last link in the last node always pointed to what? Null, right? OK, we actually call this which? What do we call this one? This is the head. OK, it's actually there's a pointer that says, hey, that one's the head. OK, and this one, I think I mentioned the other day, this one's actually called the tail, right? And I don't think we actually kept a pointer to the tail last time. But we could have if we wanted to. That just means the last one. And this one means the first one. OK, and that's how our linked list worked the other day. OK, some of the issues with linked lists, these what we call singly linked lists, are that if you're down here somewhere and you need to get to some other link that's back here, you have to go find the head again and then walk all the way through it, right? Like, for instance, if you were going to print out this linked list backwards, right? What would you have to do that? You want to print the last one. So you go to the head here, and then you walk through it until you find the last one, and then you print it out, right? And then you go back to the head, and you walk through until you find the second to last one, and you print it out. And you go through, and that's not necessarily the most efficient thing to do, right? So that's kind of one of the limitations of a singly linked list. All right? However, there is a better way. OK? You can do these things called doubly linked lists, which means that instead of just having a link, right, you've got a link to the next node, which we'll call next, right? Next. This one actually, next, goes to null. And now we're going to just do a link in the other direction, too. We're going to say, let's make this one, we'll call it prev for previous, OK, and have this one go to the previous node. OK, and then our head node actually also has a previous. Where do you think this is going to go? It's going to go to null, right? And this is going to be our previous node as well. OK, and well, it's up there. I guess it is up there. So we can now traverse this list in either direction. Remember what one of the other limitations about linked lists were? If I want to delete a particular node with a singly linked list, what did I need to know about to delete that node? Remember? Yes? You need to know the location of the previous node. Yeah, so if I want to delete this one, I have to know where this one is so that I can get the information to the about this one, or I should be able to, so I have to set the next of this one to be the other one that I'm trying to, because I'm removing this one. OK? So you need to know that. Now we're going to be able to write a little code that doesn't worry about the fact that we don't need to know the previous node, because we can go to this node and we can know what the next one and what the previous one is, and so we can deal with that then. We can go in both directions and find things out. So it makes things a little bit easier. It makes things a little bit harder in the sense that you have to take care of both the next and the previous pointer. Okay, so I mean, there are trade-offs to this, but it makes it a little bit easier to do some things and a little bit harder to do other things. The harder part is writing the actual code to do it, which we'll go through. But what's nice is once you do that, then everything else becomes a little more efficient. OK? All right. So here's our new node class. We have to change things about the node themselves, because now it doesn't just have a link pointer. It's got a next and a previous. So really, the only thing we've changed here, OK, is, let's see, that's going to be the same. That's going to be the same. Set data is going to be the same. Set next, which used to be set link, I believe, is now set, well, it's now set next, and it's going to set the next node. I put it over here because of the space. This should probably be on the next line. This one says set previous, right, which is going to set the previous link in our node. Okay? And now our private variables for our node, we've still got the data in there. And now we've just got two little pointers, one that goes to the previous node and one that goes to the next node. Okay, so that's really all we have to change in the node class. Okay, a couple different things in the node class. All right. Our node constructor, well, all we need to do is set the next equal to null and the previous equal to null. Before, we just had to set the link equal to null. Straightforward enough, I hope. Okay. And let's look at now. Before I didn't do this, I said we would today. Before, we just had a main function that had all these extra functions in them. I'm going to create this new class called a doubly linked list. And it's going to have a lot of functions in it that we need. The nice thing about this is it's going to know, the linked list itself is going to know about its own head, so we don't need to actually keep passing the head pointer back and forth. Okay? It's also going to know about its tail as well. Let me see. It is going to know about its tail as well. And we're going to do that. Constructor, some getters. Okay? And a bunch of functions here. Now, we can actually write a function that inserts after a particular node. So if we want to insert something in here, we're going to pass this node in, and it's going to be inserted right here. Okay? If we're going to insert before, we can do the same thing. If we want to insert it before this node, we can pass it this node, and it will insert it here. Okay? And all we need to do is pass in the node before or after that we're inserting before or after, and then the value that we're going to give it. We can also insert at the beginning, which is right at the first one, or at the end. And the only difference between those two is going to be that we know that it's the beginning or the end. Otherwise, we would have to have a particular pointer or node that we're going to do it at. But if we know it's the beginning, well, we know where the head is, and we can pass it in. Okay? We have simplified our remove. All we need to do is know the name of the node, and we can do all the magic necessary to do that. Okay? And then finally, we're going to have a clear, which is going to say, give me back, get rid of all the nodes in the list. Okay. I'll show you the code for this in a little bit here. Well, actually, here's the code for insert after. Now, this looks kind of ugly, but let's walk through it piece by piece. Okay? Let's do this. I'm going to erase this, and we'll just build a couple right now. All right. There we go. All right. So what this says is it says insert after some node and the value. Now, let's pretend that we didn't have any nodes yet. Okay? Our head pointer is going to point to null. Okay? And our tail pointer is also going to point to null. Okay? So what we're going to pass in basically is null here, because we're going to pass in the head, actually, let's say what's at the tail. Let's say we're going to pass in the tail pointer, because we want to insert it right after the tail, right? And it's going to be null. And we're going to have some value. Let's say the value we want to put in is 2. Okay, that's what we're going to put in there. All right. So the first thing this says is the node null? If it is, and in this case it happens to be, okay, what we're going to do is we're going to say, hey, we must have an empty list. Because if you pass in a null pointer and it is a node, well, the only way that can happen is if it's an empty list. Okay, if you pass in an actual node. Okay, that's the only way it can happen. So what we do, we say, okay, well, sorry, I forgot to create the node first. First thing we do is create the node. Then we actually set the data. So we've got this kind of floating node here. So we're going to create this node. Okay, and the node constructor does a couple things. Okay, the node constructor says that the next is going to point to null, and the previous is going to point to null, and it's going to set the data to be 0. Okay, so we're going to do that. It's going to have 0 in the data there, like that. And then we are going to actually set the data, and we want to make it 2. So we set it to 2. OK. So far, so good? Now we're saying, look, if the node that we passed in is null, which means it's the head of the tail, we set the head to be pointing to that node that we just created and the tail to be pointing to that. Well, that's easy enough to do. Right? We now point the head over to this node, and we point the tail over to this node. OK. Is that a proper doubly linked list? Does it have a node? Yes. Does the head point to null in its previous pointer? Yes. Does the next pointer point to null? Yes. and we've got a head and a tail, and they point to the same node. So it's a proper node, correct? OK. And by the way, that's it for this if there's no node in there. Let's say we want to add another node. OK? So let's add another node, and we'll give it 3. And we'll do the same thing. We'll insert it after. And this time, we'll pass it this node. Let's see what has to happen. OK? All right. We go and we create a new node. OK? Create a new node. Okay? And we say that this points to null, and the previous points to null. Okay? And we set its value to 0. Okay? Set its value to 0. Then we go ahead and we actually set the value to what we want, which is 3 in this case. OK. All right. Then we go through here and we say, OK, is the node that we were pointing to, that we were passed in, which is this one? No. No, it's not. This one actually exists. It's not null anymore. OK? So we skip this part and we say, all right, new node. OK? There is going to be one thing that it looks like I forgot to do here. No, I didn't. I think we're good. OK. So new node, which is the one we just created, we have to set the previous. Well, it's coming after this node. So what do? We say its previous link goes back to this one. OK? All right. And then we say, OK, from the new node, set the next to whatever that other one was pointing to, because we're going to do it after this. This one happens to be pointing to null. So we're going to set this one to null. It already happens to be null. So we're going to reset it to null, which is fine. So now it's going to point to null. OK? And then if the new node is now pointing to null here, what does that mean? That means this has to be our last and final tail. Or it has to be our tail, which is our last node. So we have to say, make the tail equal to this new node. Okay? Tail equals new node. Like that. If it wasn't the last, if it didn't point to null, well, what you have to do is you have to say, all right, you have to take the next one and make its pointer point back to it. I'll show you that in a second when we'll do one more insert here. Okay? Any questions on this so far? I'm going a little slow just so you kind of get the idea of how this actually works. OK? Let's set another one. We'll make the next one 4. And we'll do it again. And what we'll do is we'll say insert after this node here. OK? Insert after this node. OK. So, did we set this one? Did I skip the line? Let's see. Sorry, I forgot to do the last one. The final thing that we do, a node set next equal to new node. Yes. So you should have checked that. So that means is set the next one for the one that we are doing after to that. There. Now we've got a good linked list, a doubly linked list. OK. All right. So let's do it again. Let's put another one that we're going to have a value of 4 right after this one. OK. After this one. All right. Back to the beginning. Create a new node. So we'll create a node I'll do it right up here. OK, because it is going to go between those two. OK, we're going to create it. We're going to make it point to null. And we're going to make it the previous point to null as well. And we're going to set its value to 0. Then we're going to go and set its data to 4, like this. OK, and we're going to come down and we're going to say, is the node that we passed in, this one, equal to null? No, it's not. So let's go down here and do this. The new node set previous equal to the node that we passed in. OK. So our previous is not going to point to null anymore. It's going to point to here. OK. Set the next equal to what the previous one was pointing to next. Right? So what this one's pointing to needs to be what this one now gets pointed to. Here. That. OK. All right. And then if the new node next is null, it's not. It's pointing to an actual node. OK. So we skip that. Otherwise, we do this. We say new node next, which is this one. The previous has to point to the new node we just put in there. This one now has to go. Oh, it's going to look ugly because I'm going to cross. Don't cross the streams. OK. That's what that. OK. So that one's there. All right. I could probably do it this way, so I don't actually You guys know the Ghostbusters reference, right? Okay. Whew. Okay, so there. Now that's pointing back to there. And then, finally, we say the node needs to be, the next of the one we pointed in needs to go to our new node, like this. I guess it wouldn't have crossed if I done this, like this. OK. Have we just inserted a new node properly? I think we have. Right? We didn't need to change the head of the tail because it was in the middle there somewhere. We made all the next pointers point to the right place and all the previous pointers point to the right place, and we're good to go. Okay? That's how this works. Yes?
Because I'm a little bit confused about the second else, where we made the previous pointer of 3 point to the previous, or point to 4, because you use new node twice.
We actually, OK, so new node, which was this one, OK, we're saying get the next, what it is pointing to, which is this one. That's what we're saying. And we're saying set this one's previous back to this one. So it's kind of that nested thing where first you get the next one, then you set that one to that. We could have done this in 2 steps. We could have maybe made it a little more clear by first saying next point, next node, and then set the previous of the next node. So it might have been a little more clear if we'd done that. But yeah, it does get a little crazy when you start thinking 2 ahead. It's like that, like when you're talking about chess. You got to think a couple moves ahead. It's the same thing here. You have to think a couple moves ahead in that sense. Good. Other questions on this? OK. All right. Let's see what else we've got. So that's the insert after. We've also, of course, got an insert before, which looks very similar. I don't think I put that in here. OK. No, I didn't. We're back to the definition here. OK. There's an insert before. There's an insert after. We're back to the definition. OK. We've also got some search things here. Cool thing about a doubly linked list is you can search both forwards through the list and backwards through the list, because you've got all these previous pointers. So you could start at the tail and go this way and search backwards. And depending on the ultimate use for this, that might be what you're trying to do, right? You might be asked to pull items off the end of the list, or that a recent item was the one you're searching for or something. Well, you go to the end and you search backwards through the list, and you can find it. OK? This one's an interesting one. This is what I call this is the Google interview question. OK? What they do is they say, you'll go to an interview at some tech company or something, and it's a programming interview, and they'll stand you in front of a whiteboard or a blackboard, and they'll give you a piece of chalk, and they'll say, OK, you have a doubly linked list. Please reverse the list. Write that algorithm for me, right? And you'll have to go, OK, and you'll have to write out the reverse algorithm for them. And they'll ask various questions about why you did something, this and that, and it's more of a discussion, right? But they'll expect you to A, know what a linked list is, a doubly linked list is, and B, be able to use the ideas that you know about nodes and things to write that reverse function. Okay? And that happens, in a lot of different tech interviews these days. It's the way they do their interviews. They want to know that A, you can program, and B, you can think, which is the algorithmic part of it. Okay? All right. And then this is all we have in the actual linked list. We have the head pointer and we have the tail pointer, and then we have the number of nodes. You know what? I forgot to update that on the add node. So we should be updating that. In this case, we actually haven't. So I'll change the code and make sure that it is that way. OK? All right. Now I'm going to show you something. So we just did this on the board. OK? We just did this on the board. I'm going to show you something that you can use if you want to during your own debugging. OK? And it's kind of clever. Now, unfortunately, the font is going to be really small in here because I can't actually, that I know of, control it. But I do want to show you what this is. So this is, by the way, this is the main program that we're running here. Okay? We're going to create a doubly linked list. Okay? Little pointer to a new doubly linked list, which makes that sets that head pointer and tail pointer to point to null, and it says there's no nodes. And then we're going to insert some things at the beginning. We're going to remove some nodes. We're going to insert at the end. Da 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 da. Okay? And we'll walk through what that's actually doing in the following way. Okay? All right, now let me see if I can do this. There it is. OK. This is a program called DDD. And it is located on your on the lab computers. Okay, it's in all lab computers. And you can if you're graphically attached to the lab SSH, it'll work too. Okay, and you type DDD and it opens up. And what it is it's a graphical interface to a debugger. And I think I mentioned this in the other class the other day. But the debugger actually will run your code one line at a time, or one instruction at a time, or whatever level of granularity you want. Okay, and it'll stop, and then you can analyze what's going on underneath the covers. Okay, you can go down a path doing this that will take that will get you it'll take a long time to actually dig down into these things. But for basic kind of stuff like what we're talking about here, sometimes you just got to go into the debugger and find out where your program's A, crashing, or B, why it's giving you data that's not the data that you expect. Okay? But it's got this cool interface here where it shows you the data, and it actually creates these little cool pointers for you too. Okay? It was really neat. I haven't seen a debugger that does this quite this way before. What I've done is, and if you want details about how this actually works, I better make this window smaller. Hang on. During office hours, then come by and we'll. Oh, if that works. Actually, I think that worked. OK, what we'll do is we can go through it. We can go through it with you and show you how this actually does this. But for now, here's what you need to know. I have said to the program, here's our main function. Stop when you get to this first line here. OK, stop when you get to this first line, and I want to analyze what's going on. Okay. Any questions on what's going on here first, like how this is? OK. It's going to go to this line. I've already stopped it here. I have gotten to this point where it says doubly linked list, new double. It hasn't even done this line yet. OK. In fact, it shouldn't even really know about this variable yet, but it seems to. But it says that there's this address. Don't worry about what that is. But know that it's pointing to something. I guess it actually has. I guess it's already created this. But no, it hasn't. Sorry. These are random numbers right now. Okay, that is not how many nodes we have, right? There are not like 1 trillion nodes, right? Okay, and it's just going to say the head and the tail pointer. Now, again, I just realized I forgot to actually update node count, so pay no attention to that one as we go along here. I'll fix it in the code online. Okay, what we can say is step through this and then go to the next line, and it stops at this next line. Now it is actually called the constructor for doubly linked list, and it has set up our cool little node here. Notice that it says that the head is equal to null. 0x0 means that it is an address, and it's in hexadecimal, base 16. You don't need to worry about, and the nice thing about this is you actually don't need to worry about all what that number is, except to know that 0x0 means null. Okay, it means 0, which is null. Okay, and it sets our node count to 0, which we'll have to ignore because I messed up and didn't put that. Okay, let's step through the next one. So I got this print list in there. Okay, you could, if you do the little step command here instead of next, if you do step, it will actually go into the print list function and go through each line in the print list function. I am not going to waste your time doing that right now. Okay, just suffice to say that it's going into there, it's doing that function, and then printing out what it needs to and coming back. So hopefully this will work. There we go. There are no nodes. So what it printed out down here was a little bracket, meaning there's no nodes. Okay? If there was, it would be bracket and then the number of nodes separated by a comma. Okay. Now, insert at beginning. Okay? We just went through we went through insert at the end. Okay? I'm not sure it's going to actually find this if I do the step. It may find it, but I'm not 100% sure it'll find it. But let me show you what happens up here instead of stepping through the insert at beginning, because it's analogous to the insert after, right? Or insert at end. Right? It's analogous to that. It inserts at the beginning and changes the pointers appropriately. You can look at the code a little bit later. But let's see what happens here. OK, so I go and I insert 1 at the beginning. Aha! Now look, it tells me that the head has some pointer value. Don't worry about what it is right now. And the tail has some value. And they happen to be the same. And we hope that's the case because now there's 1 node. Well, let's see if we can find that node. If we double click on, let's see, there we go. Ha-ha. There's our node. Right? And the head, you can kind of see that. I know the font is really small. That says head. If I double click on the pointer, hey, look, the tail is also pointing to that node. Okay, it's not backwards like you might, well, Actually, it's almost exactly what I had on the board there, right? OK. The cool thing here is you can actually drag these guys around, too. And it does sometimes mess up. But you can do this. All right, but let's see if it did it. We asked it to insert at the beginning a 1. And look at that. Our data is 1. And now this node points to null. The previous value, it points previously to null and next to null, meaning it is both the head and the tail. OK, we get that? All right, it's pretty cool. Let's print the list again. OK, I printed the list. And now down here, it says that there's a value of 1 inside that list. That's not the number of nodes. That's actually the data value. OK? All right. All right, let's remove it. Why not? OK, this will probably make some of these boxes change a little. OK, if we remove that node, which also involves doing what? I mean, if we're going to remove this node, we need to destroy the node, and we need to set our head and our tail back to null. And not only that, we need to, if there were other nodes, we would also need to make the pointers go appropriately. Okay? Again, I won't go through that actual code here, because I'm kind of demonstrating this one for you right now. Let's see. If we do that, oh, there we go. Everything kind of disappeared in this case. And then we'll get it back in a second. And printing the list says that it is nothing's left in the list again. OK? All right, let's see if I can make this happen again. Here we go. This, and display it. There we go. OK. And we're back to where we started. OK? We have got a head and a tail pointer null because we just deleted the one node that was in there. Not sure what this one's doing floating around here. OK. I bet I can go up here and say either hide or undisplay or something like that. Maybe I can double click on it. And there, undisplay. There we go. OK, so we did that. Let's see. We are still down here somewhere. Oops, we are right. Oops, did it go back up to me? No, it didn't. We are down here. I'm going to just go to the next and see where it should tell me where we are here next. There we go. OK, so now I inserted something at the end, another function, which actually the one we just showed there. And now we've got one node in here. And the head and the tail both point there. And the data is 1. I just did the same thing. I inserted 1 again. OK, print the list again. And 1. It's got 1. Good. All right. And then insert at end. Now we're going to do something. Now we're going to actually do a little bit more work here, right? We're going to insert at the end after this node. OK, insert at the end. If I click next, there it is. OK, now take a look what's going on here. Now we've got our head, which is here. And its data is 1. We've got our tail, which is here. Let's see where the previous and next of this and the previous and next of this point. OK, I won't do the previous step, but the next of the first one points up to this guy. OK, and the previous of this one points down to this guy. Do we have a linked list? Sure we do, right? And you can see that the next to this one is null. Well, if I move my mouse. The next is null here. And the previous of the head is also null. We're good to go. OK, all right, let's see what else we've got here. We have got, well, we're going to print the list again. Print the list again. And it's going to be 1 and 2, which is what we've got. Insert at the end. OK, so let's see. We've inserted at the end. And now the window's getting too big, which is kind of a pain. But let's see if we can just do this real quick. I won't do this too much longer here. But now we've got another node which came off of this one. These values are going to get a little bit. Sometimes it gets it. Sometimes it doesn't. Oops, I did the wrong one. There. This one needs to go here. Right, because, oops. There, we'll do it that way. There we go. OK, so now look what we've got. We've got our first node, which is the head. The head points to the first node. This node next points to this node. And this previous one points to here. So let's see what this guy's pointing to. His previous hopefully points back to the one before it. And his next points up to this one, hopefully. And there we go. OK, boom, 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 boom. OK, can you see how this might be useful if you're trying to debug some of this code? You can see where all the pointers are pointing. You can see what the details are. And you can kind of dig in a little bit. OK? And once you get into, say, comp 40, let's say, knowing some of these things about where these pointers are actually pointing is probably appropriate as well. OK? All right, so I won't keep going through all this, but it's going to keep creating, inserting beginning. it's going to give you the node. We're going to get the node at the second value here. That's OK. You can see it in the code when you look at it at home. And then we're going to insert after that, which is what we're going to do. And this gets really kind of, whoa. If you have a bigger window, you can actually do it. And then it prints the list. So right now, here's what we've got in the list. 4, 1, 2, 5, 3, right? And then we get to this fun reverse function. Okay? In a second, we're going to kind of walk through what actually has to happen in that reverse function to do that. Okay? But suffice to say, all these different pointers will hopefully start pointing in different directions after I do this, right? Oops. Yeah, there we go. It's tough to see because if you wanted to, you could go back and see this. But now, it went from 4, 1, 2, 5, 3 to now the list is 3, 5, 2, 1, 4. 3, 5, 2, 1, 4, which is backwards. Okay? And I'll show you that code coming up here in a second. Okay. Questions on DDD? It takes a little bit of time to learn how to use this program, right? Like this window seems to disappear sometimes, so you click here and it comes back. And if you click on a particular variable, you have to go up here and you have to type display. And I mean, it takes a little bit of time to get used to. But once you do get used to it, you can go through that. And if you don't like this whole graphical interface thing, you can certainly you can write the commands down here, which will give you a lot of the same functionality. OK? All right. Any questions on that? Awesome. OK, let's look at the reverse function while let's see if I can do this. Oops, that's not it. So what I want to do is minimize this. And I don't believe I actually have the reverse function up here. So I'll get it in 1 sec. Nope, that's that. All right, let's see. It should be here, which is good. And it is in our doubly linked list. And reverse. Here we go. OK, now I just have to make sure that I do this. So I get all that in there. And oops, it's not going to actually let me do that, but I'll do this to get at least up a little bit. OK, so here's what reverse is going to do. It's actually not that long a function, believe it or not. That's about as high as I'm going to go. OK, reverse says the following. It says start at the head. OK, and let's do it with this list. I know the screen is going to overlap a little because I have no idea how to get that, so that doesn't work, but should be able to see it. OK. All right. What it's saying is start at the head. OK. Create a little temporary pointer. I'm going to call it a temporary pointer, which initially is going to point to null. Null. OK. All right. And then another pointer, which we're going to call the current pointer. OK. Which is now going to point to what the head points to. OK. Crossing the streams, watch out. OK. All right. And then the first thing we're going to do, if we want to reverse this list, what becomes the tail afterwards? The head becomes the tail. So what we do, and by the way, we've actually kept a pointer to the head because we're going to use it in a minute. OK. The head now points all the way over to the tail, like that. OK. And now the head and the tail happen to point together, but we're not using this yet, so it's OK. All right. Then let me go down here a little bit now that we've done that, and we'll look at the rest of this function. While the current node we're on is not null, do the following. OK. Set temp equal to the previous of the current. OK. So right now, OK, temp is going to be equal to null. It's still going to be equal to null. OK. Then set the current to the previous of the current next. OK. So we're going to set, let's see. We're going to get the next one from current, which is here, right? And we're going to set the previous of current to point to there. I bet if we go through this whole thing, the arrows are going to be all over the place here. But does it make sense that if this is now going to be our last one, its previous needs to point to the previous one, which was the next one, right? Because we're reversing this list. OK. Okay, all right, let's see. Okay, and then current set next equal to our temporary one. Okay, so now this, our next is going to go to what temporary is pointing to, which is null. Okay, keep in mind, we're reversing this list. Okay, so this is now the end of it. So I should write down what this is. This is actually, well, this is the previous, right? And this is the next. Yes? Yes? We want the tail to be, did I do that wrong? Hang on. The first thing we did, we said the tail is now equal, oh, you're right. So I should have made the tail equal to the head. Yeah, that's what I should have done. Sorry, thank you very much. So this one, I did do that backwards. That one's there, and then like that. And then our head is still pointing to, our head is still pointing to our head. We didn't change any of that yet, did we? No. OK. That's still pointing there right now. It will change eventually. Good, good catch. Thank you for catching that. All right. OK, so then we're saying current set next to temp. OK, did we do that? Yes, we did that. So next is now going to temp. So this is now our last node. Hopefully it points to the null next, and previous goes to what is now going to be the previous node. All right, then we have a couple other things we have to do. We have to set the current equal to the previous of what it's currently what it is now. So this, instead of pointing here, we're going to make this one the current node. Okay, this one becomes the current node. There. Okay, that one becomes the current node. Okay. All right, and we're actually done with that right now. We've actually made the appropriate changes that we need to, and we're going to go back again. Is current null? No, it's not. Temp is now equal to what current was previously, what current points to prev. So that's going to be here. This is now our temporary one. Okay? So before temp was just null. Now we've got another one, which is temp. Right? Now that's pointing here. Okay. Current is now we're going to set the previous of what the get the next of what current points to. Here, the next of what current points to, and set the previous of that one. So this one, set the previous of that one to the, sorry, I lied again. Set previous, this is why it gets confusing, right? Because you got to go through this and you got to go, OK, you got to think it through. This is why I wasn't very good at chess, I guess. Right? All right, let's try this again. All right. So we're going to set the previous of the current one. So this is our current one. We're going to set its previous, which is this link here. And we've got to set that to what the next is pointing to. So we're going to swap this. So this is not going to go to the, this one is not going to go back here now. It's going to go, oh boy, this is going to get ugly. Let's see. No. Dotted dashed line there, right? Because it's got to be, because we're reversing it. Okay? It's previous got to be. Yes?
So the main purpose is to swap the head and tail, and also swap the previous and next.
Yes. And it's for each individual node. It's to reverse the whole list. So this one becomes the head, and this one becomes the tail, and all the other ones in the middle swap direction. Okay? It's actually not that, I mean, if you look, it's not that much code. It's a matter of getting it to work right, which is there. I don't want to kill everybody with this by keeping going through too much more of this. But we were here, right? So now we're here. Current set next to be what temp is pointing to. So in other words, this guy, the next pointer, instead of pointing here, has to point back to this one, which means we've now reversed it. Right? We reversed the way this node is pointing. This guy, points back here, right? And unfortunately, it'll end up being like a mirror image of what we want, right? And then we need to move our current to the previous of the current. So the previous one of the current is here. So current will go from here to here, and rinse and repeat, right? We're going to do it one more time. In fact, that's all we have to do now. OK, so temp is now current. temp is now get previous of the current one, which is here. So this is now where temp is pointing to. Temp is now pointing to this one. It's like, this is like a horrible rotary here. It's one of those like too many different arrows going back and forth. OK, so and then set previous. OK, here we go again. Set the previous of current. So current's previous, which is this one. We need to now set it to the next. We need to swap those ones, right? We need to set it there. Good news is that it's going to go to null. Oops, non-ULL. OK, it's going to go to null because it's going, this is the previous, right? Because this is now our head, and we want the previous of our head to go to null. OK? All right, and then set next equal to temp, which is here. So our next of this one goes back to here, right? OK, and then current equals get current previous, which means current is now going to point to null because the previous one of this now points to null. OK, rinse and repeat, right? Is current now equal to null? It is. Whew. We made it. And we go back, and the final thing we say is if our temp equals null, which it doesn't, right, our head is now equal to temp get previous. If temp is not equal to null. So it's not. So our head needs to go to temp get previous, which is temp get previous here is now our new head, which is what we tried to do at the beginning. OK. All right. OK, now, I don't think I get a job at Google. Maybe that's it. Can we see what's going? Can we walk through this list now and see if we've done it right? At least we'll do that, right? Let's look at our head. Our head points here. That is the new head of our list. Where does its next pointer point? Its next points to here. This guy's next points to the next points to here. The next points to null, which means this is the tail. OK, so far so good. OK, let's start at the tail and go backwards. Does the tail point to its previous points to the one before it, which is good. This guy's previous points to the one before it, which is good. This guy's previous points to null, which is good, which means at the end. Whew. We've actually reversed this. OK, it might have made more sense to try to move the boxes, and maybe we should do that. Maybe I should do that some other time, right? But bottom line is we successfully reversed this. OK, there is a way to reverse a singly linked list, which you might also want to consider thinking about. OK, questions on this? Yes.
Would it be faster to do this with recursion, or
Good question. Would it be faster to do this with recursion? Faster is a tough term. It might be. This one would probably be a little tricky to do with recursion, actually. I haven't looked into it, but faster, probably not faster. Possibly less code, maybe. There really aren't that many pieces of this, right? You might be able to just say, recurse through swap next and previous, and swap the next. But you do have to do, especially with this doubly linked list. You remember you have to work on nodes on both sides of you, which is a little trickier. OK, good question. Yeah. Yes.
What I got is this is trying to swap the pointers of each single node, and
Yes.
so maybe instead of doing this, try to swap the pointer from 2 to 4 and the pointer from 4 to 2.
Yeah, you can do that, right? Like so your question is, are you just trying to swap 2 to 4 and 4 to 2 and 2? Yes, but you'd better do it in a rational way. Like you have to figure out could you guys maybe rewrite this to be slightly less, well, wordy is not the right word, slightly less numbers of lines of code? Maybe you could, right? And maybe that's an easier way to think about it. But if you walk through this, now, I mean, I know I was flailing around on the board trying to get all the pointers to work right, but if you go through each one of these lines, you'll see that it is actually relatively straightforward about how to do each little step. Break it into steps, and that's going to be the important part. OK? Other questions on this? No? OK. All right. So that's how you reverse a doubly linked list, and you end up with spaghetti over there. But if we rearranged it right, it would actually look OK. All right? OK. All right. So finally, last little thing I want to talk about here. We can have these things called circular linked lists. Okay? A circular linked list, all that is, and we don't need to spend more than about 30 seconds on this, all that is saying that in the previous node to the head is the tail, and the next node of the tail is the head. Okay? What that means, right, is that going in one direction, in fact, you can do this with singly linked lists too, and sometimes they do. Going in one direction, you can walk through every node in the list. Okay, you just do that. What you have to do is you have to keep track of that first one, right? If you forget to keep track of the first one, then you'll just go on infinitely, right? You just keep going, and who knows where you keep going forever. But if you start here and you want to go forward and do something with each node, right? Let's say in your nodes, in your list, you want to add 1 to each node or something, right? Well, what do? You go to this node, then you have to go through the whole list. Well, the easy way to do that is if you happen to already know one of the nodes in the middle somewhere, you can go, OK, I'm going to do this one, then this one, wrap around to this one, do this one, I get back to this one, and stop. Okay? You certainly could also just go to the head in a regular linked list and do the same thing. But it helps out that you can do that. And sometimes this is good for various ways of traversing functions. Or traversing things like mazes and things, right? I mean, if you're going to do mazes and things, you might want these pointers to point back to somewhere else. So you can do that. Yes?
So the last node, it has an arrow that's pointing to the thing.
Yeah, that I should have taken that one out.
Okay.
Yeah, thank you. Should have deleted that one. Yeah. Sorry, that was confusing. Other questions on that? That's all circular linked lists are for, OK? You use that in various buffers and things where you might want to use some data and then have a fixed amount of data that you're wrapping around. We'll use it in what we call queues a little bit later. So we'll see that. Yes?
Anytime we had checked for null previously, would we have to check for either tail or head in this case?
Every time we check for null in this case. Actually, with a circular list, you don't ever get to check. I mean, checking for null doesn't really mean anything because there aren't any nulls in this case. Right. That one aside that I should have deleted. But yes, other than that, it's good. Other questions on that? All right. We'll see you guys Monday.